All right, hello AP Scholars. We are taking a look at the answers to question 1 from the free response questions practice 1 assignments. So we're looking at that frog one to start with. There's another video on question 2, so check that out as well. Oh, hi, William. We're writing this a frog simulation class has been written. We will be writing one of the methods in part A. Part A asks us after many, many letters and words to write the simulate method. So I'm going to grab that, copy and paste it to my editor. I'm using Atom. You can go to atom.io. I think it's a fantastic editor to use. It doesn't compile. I mean, you can hook it up to a compiler. It's amazing. But it is what I want to do. If I was doing the AP exam, what I would want to write in. Because it does syntax highlighting. How, you ask? Well, it's not saved as a .java file. So if I go and, how do I say? I, there we go. I'm not sure why it hides the bar. I could press Alt key to make it show up. I could press Control S would have saved as well. I can go save. Let's go to, oh, this is my son's tennis game, Miles's projects. I'll just save it on desktop, whatever. What is this? FRQ practice 1. So I'll put my answers in here. And of course, to make it say, to highlight for Java, I'll save it as a .java file. And check it out. Boom, it's giving me some syntax highlighting. It also gives me the ability to tab. I can select text and press the control / to comment stuff. There's a bunch of nice features, and I think you'll find it's pretty good. It beats Notepad or something. And I think it's actually better than BlueJ for writing free response questions. You don't ever have to accidentally press compile and notice that there's things that are missing that you actually don't need to answer the question. Like here, I just need to write a single method. Not going to write the rest of the class, so that's perfect, right? No errors will result. Okay, so let's go and take a look at what I'm supposed to do for the simulate method. So simulate is going to be a method that's going to simulate this frog hopping concept. Oh, and I believe um, we have to take a few things into consideration. So it's got this nice little frog simulation class information here. It tells us we have our goal distance. So this is the goal that we're trying to get to, and that's going to determine sort of whether or not we return true or false. It's all about that goal distance. If at the end of the simulation we reach, or sorry, it's actually not the end. If at any time we reach the goal distance, then we're returning true. And if at the very end, if we actually get to the end of the simulation, if nothing else has caused us to exit out, then if we haven't reached our distance, then we will return false. So that's a good thing to keep in mind. And also we have a couple other things to know about. If our frog ever gets into a negative position, we're going to return false. And I think that's basically the story there. Okay, so we're going to write simulate. Oh yeah, I guess the other thing we have to know is there's a max number of hops. So we don't know how many that is. It's sort of built into the frog simulation, and that's the number of times we get to hop. And that's sort of going to determine how many times we loop this method. So let's do it. So I am going to probably write in some kind of for loop here to do the hopping. And I guess actually before I do the for loop, I'm going to need some variable to keep track of the total distance that they've hopped. So I'm going to put in sum equals 0. Should always initialize it to 0. And then I'm going to put in my for loop. So I guess I'll use I as my counter. I could be like clever and go with hop, but I'll just do I. It's not going to give you extra marks if you are clever with your variable names. So I want to keep on going as long as I is less than I'll go back to the document, the max number of hops. So that's max hops. So that's where that comes into the question, right? Because this is going to be hop, 0, hop 1, hop 2, hop 3. Eventually you'll get to max hops and we'll stop. And each time I'll go up by 1 because hops are counted that way. Okay, so what we're going to do in here is basically we'll hop, we will add that to the sum, and then we'll check our possible conditions for failure or success. And that's the story. So the way that you hop, according to the question, is that you're going to use hop distance. Hop distance returns a number that represents how far the frog hopped. So, we're not sure how that is determined. Is it connected to sensors on a frog's butt? I don't know. But it doesn't matter. We don't need to know that. That's one of the beauties of object-oriented programming. We're just doing this part of the program. So hop distance is going to be important. And you can see how hop distance works. Actually, I won't put a semi in there. It shows you in here. It's in right here. It shows it returns an int. So we can expect this to return an int. So we can stick that in some kind of a statement. So we can say like sum plus equals hop distance. So that's essentially the frog hopping and us recording it. So there's a couple of conditions now that can happen. One is that if it hits a negative number, so sum is less than is the total, by the way, not just a single hop, but the total hops. If it's less than 0, 0 is okay, then we immediately return false. It's gone off the the test environment, and so we need to just say false. It has not succeeded. Also, as soon as the sum, I should double check. I think it's meets or exceeds the goal distance, then we should immediately return true. We don't have to keep on going. In fact, we shouldn't, because it might hop backwards and leave the goal distance. So, we just want to know if it ever reached it at any particular hop. So let's go back to that question description, and that's called goal distance is how far we're trying to get to. So I'll say, hey, if sum was greater or equal to goal distance, well, that means we can immediately return true. And if you wanted to structure these sort of with braces and things like that, that's entirely okay, of course. If an if statement has just a single line that is the body of the if statement, the clause, I guess it's called, you don't have to put in the braces. I'll leave it up to you how you want to format that. It's entirely correct to format it in either way. So I'm just going to confirm, yeah, it looks like it's greater than or equal to, because 24 and 24. Okay, and then that's basically it. The only thing we're missing now is we have to let it go, and then if, say, it never goes negative and it never exceeds the distance, then I guess it never got there. So at the very end, we should probably just return false. So if this loop ends and it hasn't returned, remember when you return, you leave the method. It's done now. It can't do anything more. If you leave the method, then you'll never get to this statement. So if we get to this statement, it means we never got a negative one and we never got to our goal. So looks like our froggy failed. So that's the answer to question number 1. So I'll just put this as question 1, part A. Now I know that this is a Java file, so I'll put that as a comment. So we'll do question 1, part B now. Notice, actually, whoops, it replaced it with a break. Notice that this is not a lot of code. How many letters? You read like 2.5 pages to do what essentially amounted to a coding back question. So it's a very verbose coding back question with some tricky stuff because it's embedded into a class and you have to understand that class and how it works. Okay, so part B, it's going to probably be a similar type of thing. We're going to get into some, coding bat like code, and it's going to be a bit to read. So here it says write the run simulations method, which performs a given number of simulations and returns the proportion of simulations where this frog successfully passed the goal. So basically, we're going to be writing this method here, public double run simulations int num. So public double run simulations int n. So I'm going to be calling this method simulate n number of times and recording how many times it was successful, and then I'm going to return the ratio as a number between 0 and 1 of the number of successful simulations, the ones that returned true, the ones that actually reached or exceeded the distance. And by the way, for this question, you can assume that this code is correct, even if you wrote nothing for this question. Say you left part A blank, you can still write part B and just understand what it's supposed to do and what it's supposed to return. So again, I'm going to write a for loop. So for int I equals 0, while I is less than n is our number of simulations, I plus plus. This will allow us to do n simulations. And I'm going to keep track of the number that were successful. So again, I'll have int sum. And then I will run the simulation, and then I guess I will check to see if it was true. So this question is asking you, do you understand how to call this method that you wrote? So you can do simulate like that. That would call the method. However, it doesn't, what's the word I'm looking for? It doesn't record the value here. It does run it. It runs a simulation. It returns true or false. It doesn't record the value. And by the way, you could say this dot simulate. That would be entirely fine. You could definitely do this dot simulate. But because we're in the class, we don't have to do that. So I'm going to just leave off the this for this example. Okay, so I can do like Boolean x equals this or something. I could also just embed this in an if statement. I could just say if simulate. You could say equals true, but because it returns true or false, you could just say if simulate. So this will run the simulation and return true or false. So if we simulate and it returned true, then I can sum plus plus. Okay, so this for loop will basically run this simulate method n times, and every time it returns true, we will up sum by 1. So then we get to the end of this, and that's after the for loop. Now we have to do the calculation where we determine the ratio that we return. So we can't actually, I can just make a double ratio. You know, it would be nice to do something like n divided by sum. Wait, is it the other way around? Sum divided by n. It'd be nice to be able to do this, but remember these are both ints. That's an int, and that's an int. So this will result in integer division. So that's not what we want to do. So easiest way to solve this problem is not make this an int, make it a double. Remember, when you have a double in a division statement, either at the beginning or the end, as just the divisor or the, oh, I forgot what the words are called in a division, quotient, divisor, oh, I forgot. But anyways, if you have, one of these things is a double, it'll do proper, decimal division. So that's my best way of solving that. You could also do some casting as well if you wanted to cast one of these to a double. You can't cast the entire answer to a double, but you have to cast one of these first and then that. But this is just easier right here. Oh, so easy, so easy. So then we can return that. We can return the ratio. And you could just return, actually, you don't have to do these two steps. You could just return that, and that would be fine as well. So yeah, this is actually, it's not a lot of code to write, but it is tricky, right? Like, how do you call your own method that you wrote? These are all part of what makes this question tricky, even though the amount of code amounts to nothing more than a coding back question. Okay, so thanks again for watching this video. There's another video for questions in part 2, the second question. So check that video out, and I hope you're having a great day, everybody. Take care. Bye-bye.